Alright, another draft physics video presentation. Alright, some more counter argument to the standard model BS. This part should be getting into the incredibly weak and almost silly reasoning. It is silly. They used to abolish cause and effect. A rather substantial notion of reality, and really substantial in the context of the struggle against religion, getting evolution respected as a theory, just the whole conversation about the fact that we don't have magical origins. And this is really a counter argument to everything science had pretty much figured out, which was it's a mechanical and kind of cruel and cold, you don't even need the word cruel in there, but you know what I mean, cold universe of mechanism, and everything's sort of robotic and mechanical. And apparently the scientists didn't like that either. They wanted to go back to the comforting religion of, no, there's some God who's terrorizing us. There's some God inventing the plague to punish us. The tornado blew down your house for a reason because you're a bad person or something. It's not some mechanical thing. And that's how it's that bold a statement, and it's so, like I said, you hear the story and you're just like, you didn't blow up cause and effect for this little bit of a reason, did you? It's just too silly. So anyway, no, I mean it's. I mean, I'm just saying, why are people so eager to do this? People who consider themselves intellectual and smart. Why do they think it's a good idea?
There's another situation that's much more serious than that.
Okay, so he's talking about Einstein's objection to the woo-averse.
It's not merely the world's being strange. If somebody tells you the world turns out to be chancy as opposed to deterministic, it seems to me the right thing to do is to suck it up, and to say, well,
well, I'm just saying, why would I just suck it up? Why wouldn't I say, show me this chancy stuff, and explain to me exactly how the universe is coherent, this uncaused cause stuff. If there can be uncaused causes, well then why can't there be gods all over the place?
That's not what I expected, but I'm going to have to think about it. I'm going to have to get used to it.
Yeah, why would I do any of that? Why? Because you don't have any evidence. If you had something called evidence, good evidence, well, this might be something to do. But you have magic tricks. You say because a magician can pull a pigeon out of his sleeve, therefore we have to, we have to now forget about this mechanical universe stuff and go back to religion.
To learn to live with it. It's a very different story to be told something like an electron is a probability wave, or an electron is probability, or something like that. That is.
That the universe is some stupid thing like mathematics or something. That everything's really just twos and threes, flying around, hitting division symbols or something. It's just too stupid.
That's a statement more, I don't know, somebody picks up this bottle of water and they say, look, my theory is based on the idea that this bottle of water is Elvis Presley. The right reaction to this is not, I didn't think that was true, but I don't know what you mean.
Right, so that's the right reaction, and none of you have that reaction. You just accept this theory that it is Elvis Presley because somebody drew Elvis Presley's face on it. I mean, you can see the crayon. It's a crappy image of Elvis besides. You can barely tell it's Elvis. I mean, and you fall for it. How is that? How are you, making a statement about reasoning when you're basically all evidence of a lack of this reasoning skill?
Well, that's the position a lot of us.
That's right. I don't know what idea it is that I'm being asked to get used to here. I don't know what it would mean to entertain the possibility, even if I'm later going to reject it, that this bottle of water is Elvis Presley. I just don't get that. I think it's really important to make a distinction.
Well, I don't know if that's the best articulate way to say I just don't get that. It's just that it's inconsistent with every single other fact in the universe, like tornadoes don't just land on bad people's houses. I mean, we have all this evidence that there is no other mechanism, but the physical interactions take place by physical interaction rules. And there really isn't any magical tornadoes.
Between something being strange and something just being unintelligible. Okay. If you're pouty because the world is strange, that's too bad for you. Okay.
So more mush. This whole idea that, okay, so we're going to call objections to your bizarre and bold and insanely unevidenced claims poutiness. You're pouty because we're all believing something for no good reason. So we shouldn't be a little pouty that, more than half the world believes in some frickin' fable, about magical beings in magical places conspiring to force us to behave in some special way that's going to make us good. I mean, yeah. No, that's not reason for poutiness. What is reason then?
But if somebody tells you a story that says you're going to be able to understand everything if you can just get your head around the fact that this bottle of water is Elvis Presley, the right answer is I just don't know what it is you're asking me to believe.
Our recent history.
We know what you're asking me to believe. You're asking me to believe that there is some whatever in the universe, that this magic stuff happens from the magical thing. And you can say, well, we just think it's chaos. It's random. It doesn't mean it does anything on purpose. Well, what's the difference? Magic that's stupid versus magic, that pulls not a pigeon out of your sleeve, but just the just the chemistry of a pigeon. A certain number of atomic compounds misarranged. What's the difference between poofing pigeons and poofing pigeon poo? Oh yeah, there's no difference. It's poofing.
Is full of situations in which we've been astonished to find out that a little box in the corner of the room had Milton Berle on it, and in fact Elvis Presley, when everybody knew he was in Tennessee at the time.
So nobody was astonished by that. They all knew what it was. It was technology. It was just taking pictures and sending them electronically through this air as signals, and they might not have known exactly how the frequencies work and all the other kind of crap, but they got the idea that Elvis wasn't really in the box. Shit.
So, not to say that, therefore, anything is possible, but
Right.
we are permitted to become
Look,
totally reversed in our thinking.
If we want to play this game one step further, and then I'll shut up. I guess there are.
So there's no reversal in thinking. There's just more information. So clearly, if you have no knowledge that there's forces like radio waves and other kind of things flying through the ether, that there's energy moving and banging into things, well, then yes, it does seem kind of magical. But once you know that, then all the magic's gone and you understand. So that's a lot different than what he's saying.
Things one could imagine meaning by this bottle of water is Elvis Presley. I don't know, the atoms in Elvis Presley's body reformed themselves into this bottle of water, something like that, okay? But that's not like the quantum mechanical case. It's not, the guy, you'll say to the guy, is that what you mean? The guy says, no, I don't mean that. I don't mean this bottle of water came from Elvis Presley. I don't mean this bottle of water is the remains of Elvis Presley. I mean this bottle of water is Elvis Presley, don't you see? And you have to say, no, I don't see.
Okay, now Max here is jittering like the quantum.
So this is just some more crap just illustrating. They don't even have a coherent definition of what this quantum mechanics is. So clearly Einstein's perception of it back then was, yeah, this is the woo theory, okay? And that's all it is. I mean, and it doesn't matter what kind of example I throw at you about how ludicrous it is, you somehow turn that into, oh yeah, it does that. Yeah.
Soup. So I want to find out what's on your mind.
Yeah, I was just eager to jump in and defend Einstein a little bit. Not Elvis. I'm not going to defend Elvis Presley. Don't worry. Since he was being somewhat picked on, I have a minority view that Einstein was actually correct in his objection.
Yeah, I agree with that.
That there really is nothing random. And
okay, so they'll say something this silly, right? That Einstein was correct, why their entire physics is based on him being incorrect in the fact that his objections are real objections and that he basically, through thought experiments, demonstrated their nonsense to be ludicrous, silly, childish nonsense. It can't be true if Einstein's right. Okay, if Einstein's point that the cat's not both dead and alive, it's retarded to think so, okay? Then your wooey quantum mechanics is dead too.
And to me, really, the key question, rather, is how big is really...
I mean, it's dead in the sense that Einstein stated it. So this is, again, part of their lie. I mean, Einstein's pointing out it's clearly incomplete. You have an incomplete theory. You're missing something, okay? There's other variables involved. There's something you're not seeing, but it's not magic.
the ultimate reality. You know, if an ostrich sticks its head in the sand, it's going to think that reality is somehow smaller than it really is, right? And we humans also have...
Yeah, and if you poke nails in your eye, you'll see everything all kind of bloody and messed up. So yeah, there's lots of illustrations for how you can fuck your brain. But yeah, one of the illustrations of how you fuck your brain is to believe in crap. To sit there and accept some silly story somebody told you about levitating aliens or something. And then believing it's true, and then keep looking for levitating aliens. For the rest of your life, you just sit there and try to find the levitating alien footprints. The levitating aliens left his coat and hat in my closet. You're going to go keep looking for this crap. And so they desperately look for this crap. And oh yeah, they find it sometimes in big giant piles of crap. They find a picture of Richard Nixon and say the aliens did it.
A bit of a hubristic tendency. We have again and again assumed that reality is smaller than it was, just so we could feel more important.
No, it works the other way around. You're trying to make reality bigger than it is, so you can come up with some bigger explanation for what the fuck you're doing here, except spouting some robotic gibberish that your culture and your maturation and your life experience injected into you, and you're nothing but a silly device that basically takes crap in, reforms it a little bit, and pukes it out. Yeah, you're not a magical organism doing anything magical. You're just fucking part of the flow of the goddamn septic sewage that's flowing on the surface of planet Earth.
I think the solar system was basically reality, and then we said, oh, actually, the galaxy, that's it. And then even when my grandma was a kid, they still didn't even realize there were other galaxies. So we had to expand our...
So what? Right? Yeah, we didn't know lots of facts that we know now. So yeah, it's really cool to learn stuff and become more informed. But every bit of the information, you're perverting it into some sort of verification of the aliens did it.
Horizons and accept that there's more to it than we thought. Now we know that there are many other solar systems and so on. And I don't think there's any reason whatsoever to assume that even beyond what we now call our universe, the domain that we can see, there's probably still more space going on.
Yes, and there's not going to be anything new and interesting except what you pretend to make interesting. Like somehow, oh, there's gravitational waves. Well, even if there was, who the fuck cares? Totally uninteresting. It's all this hype and bullshit that the only thing that makes any of this stuff significant. But you really think, these idiots really think you're going to find some new force or some new thing or no. You're just going to fix your mistakes. All right? You're not going to find a more sophisticated universe out there. You're going to find a simpler one because your answers are already too complicated. You've already screwed it up. You've made it into aliens when, no, it's not aliens. It's just the fact that when you put a bunch of random hay, a zillion little pieces of, whatever, corn in a pile, that sometimes the little black pieces of corn line up in such a way as they spell fuck you. Yeah, sometimes it happens. No magic. And, a million monkeys typing on typewriters for a million years probably can type. Fuck you.
And when we physicists talk about the quantum reality, we're a bunch of nerds. We talk about math because
you're a bunch of idiots. Besides being nerds, you're religious kooks and idiots. So you fit into more than one category, I'm afraid.
Leo said, nature is really a book in the language of mathematics. And this math describes a reality which is even bigger than the one we can see. This quantum reality has
Right. So again, the mathematics is just recognizing that how simple it is. It's just variables in, consequences out, causes, effects. Yeah, that's all he was saying. Okay, he wasn't saying the universe is made out of math. He's saying you can represent it very well with mathematics because it's so goddamn simple. It really is just is there 2 trees in the forest or 15 trees in the forest? And it matters how many trees in the forest. Depends on how much forest you have to see and how many trees are blocking the other trees. Not that complicated at all.
Fancy geek name called Hilbert space, right?
Yeah, so this is the real mistake. This whole fucking Hilbert space delusion. Like this somehow, this mathematical trick means anything. It's basically saying, oh, well, if I know where something is and I know everything about it in 3 dimensions, right, then I can understand if I transfer it to some other location that, yes, something has to change to make it go to the new location, and I can figure out what the changes are. But it doesn't give you the answer. You have to put in the answer to get the answer.
And then there's only one reality, this Hilbert space. It's just that Hilbert space is huge. In this reality, you can have a planet like Earth being in several places at once, which is what we mean by these parallel universes. And
well, you can't unless you break it. So, obviously if you start inventing fake dimensions, well, yeah, then you're going to screw up your mathematics because you're inventing numbers that don't exist. So, yeah, that's a problem.
then there's this equation discovered by Schrödinger, it's called the Schrödinger equation, which just tells you if you have this reality.
So let's know Schrödinger didn't like what you guys were doing either, okay? So he was on Einstein's side. You wooed this thing to pieces.
Here's what it's going to do in the future. It's very analogous to what described here by Brian about the baseball. You know where the baseball is, you know how it's moving, so you can figure out if it's going to be a home run or not. If you know what's going on in Hilbert space right now, you can figure out the future.
This you're talking about Newton's.
So again, this is this is unremarkable. And again, they keep talking as if they have some formula that's universally applicable that answers questions like, will I get a wart on my finger? It won't answer those questions. It'll just give me some sort of, oh yeah, well, I know statistically that 1 in 100 fingers or 1 in a million fingers get warts on them or something, and so then I know your finger's going to have a 1 in a million chance or that kind of crap. There's nothing miraculous about this bullshit.
If you know where the baseball is and what forces apply to it, you'll know what's going to happen.
Exactly.
But now you agree you can't do that with these particles.
No, you can predict what all of Hilbert space is going to do again. But the problem is that you start with a situation in Hilbert space where Phillips is in one place, and then you do a little Schrödinger cat experiment on him or something, and you solve the equations. You still know what the whole Hilbert space is doing, the whole reality, but the new reality now has you being in 2 different places.
I think Brian feels we're in Dilbert space.
So, yes, exactly. You're in made-up crap shitter space. I mean, it's just, again, if you put fake crap into the equation, you get fake crap out. So, yeah, put a fake dimension in, then your answer is going to be stupid.
So I think Einstein would actually feel more at peace with this notion, because at least there's nothing really random. It's just that we're being cloned.
Well, let me go back to something.
Einstein didn't say that. There's nothing really random. We're just being cloned. No, that wasn't his objection. His objection was this whole idea of cloned how. How did you manage that one? He didn't even have any notion that you were saying you were being cloned. They didn't come up with that silly explanation until Einstein already put it to them that their theory was nonsense, and then they converted it into a clone theory. So he didn't even know they were saying something that stupid.
I'd like to get back to Earth for a second. You talked about that in our experience, and similar to what I was saying in the beginning, we're used to things being in one place at one time, but we kind of feel comfortable with that. And yet, you have entanglement. Mm-hmm.
So, those are 2 separate subjects, right? So that's the other part that's kind of silly. So first, we have to recognize that there's this possibility that 2 things can be in this one thing, can be in 2 places. And then you have the idea that you can have 2 things and they're entangled. Those are 2 separate subjects. And their story is so unevidenced and so unreasonable that they haven't even made a clear distinction between, well, are you talking about the same thing being in 2 places? Like this one's identical to this one, but they're not the same thing in 2 places. Is it 1 electron or is it 2 electrons? Where did you invent the other one from? I mean, there's a big difference between ESP and cloning.
Well, Brian, why don't you walk us through entanglement a little bit? Because that's one of the great weirdnesses of the quantum world.
Sure, I'm happy to. The timing's a little awkward because I just put a cough drop in my mouth, but
You know what's amazing is I now have one in my mouth.
We'll get it well anyway.
Isn't that?
It's in both places at once in Hilbert space.
You know, earlier today we got entangled in the elevator, and I.
So, we've heard, a lot about the weirdness of quantum mechanics being the need to take on this idea that all you can do is predict probabilities or likelihoods. But actually, quantum weirdness is far more perplexing than that. Mm-hmm. So what I'd like you to do, at least for the next minute, is accept this idea that probabilities govern how the world evolves.
Right, so the first idea we have to accept is that somehow there doesn't have to be a cause for the probability. Right? So it's just a probability out of some sort of random space. Again, we know that probability exists, So that shouldn't be a disputable argument, right? We know that the roulette wheel has a probability. We know that dice tables have probabilities. We know that any system where I've created a bunch of variables, that the outcome is going to be invisible to us. Now, we also know, if you can do some reasoning, that it's inevitable what's going to happen. Okay, that the way I throw the dice, the way they bounce, the way everything happens, there'll be a real reason why Snake Eyes shows up. There won't be anything that flipped the dice by a magical mechanism. It had to hit something. An interaction had to take place in the physical universe. There is no magic. They're claiming it's magic. Okay, all of it. So the photon magically decides where it's going to go. There isn't a physical force that affects the photon. So when it goes through the slits have nothing to do with anything. The surfaces, whatever mechanism we're imposing on the photons to screw with them, to manipulate them, to cause an effect, has nothing to do with it. What's going to happen is some sort of new kind of roll of the dice that is a real random. That is the thing, the whole universe stops, the thing is this position, and somehow the universe is going to change its position and then put it back into the real universe to be manipulated by real effects. Like there's some added thing that's manipulating things besides the physical interactions. That's what they're saying. Understand what they're saying. And they're saying it based on infinitesimally small shreds of, wow, that's a weird experiment. That's it. That's all they have. A little tiny bit of unexplained stuff in the universe we view. A tiny bit of unexplained stuff, unexplainable. Just the tiniest shreds of things that we don't really understand. And they jump to this conclusion. Oh, it must be a magic verse.
And let's take it to the next step, which emerged from work of Einstein with two colleagues, Podolsky and...
Okay, so you said it emerged from the work of Einstein. I mean, this is so wrong to say that. Einstein was mocking it. Okay, you don't say, this is as perverse as someday in the future somebody will say, one of their wacky theories emerged out of my conversations where I'm sitting here overtly mocking it. And they're going to say it emerged out of my work. Their next level of woo, somehow they're going to emerge it out of what I'm doing. I mean, it is so insulting to the dead man to sit there and pretend he had any notion that you were going to pervert what he said into this crap and then put his name on it. Oh yeah, this is inspired by Einstein. No. The truth is exactly the opposite. This is it's like blaming Roosevelt for Hitler or something. It just doesn't make any fucking sense at all.
Rosen. This work emerged from the fact that Einstein, as we heard, didn't really like quantum mechanics, so he studied.
So it emerged from the fact that he didn't like it. It's just funny, right? But you made it sound like he emerged it, like it was his idea. No. Your idea, not his idea.
Try to find something that was wrong with it, or something that would establish to the people who were proponents of it that it wasn't right or was incomplete. And here's what he came up with. And let me describe it, if you will, in two stages. And I'm saying this because David is sitting over here. And the first stage will not quite be accurate, but it'll be a little bit easier to take on board. Don't jump.
So this is where the history just gets totally screwed for the purpose of the propaganda. To tell the story in some way that could possibly make sense to the idiots who are going to buy this crap. But, yeah, it won't be the real history.
On me. I'll then correct it and make it a little bit more precise. So entanglement, what Einstein found was you can have particles. Well, first of all, let me just emphasize one thing. Particles can have a property known as spin. Particles can kind of spin around like a top. And if they spin, say, counterclockwise, we say they're spinning up.
So all of that crap was not known, that particles have whatever. They had some vague notion that particles have properties. So the idea is that you have a property. You're in a specific a location. Then another property would be you're going a certain speed. Another property would be you're going in a certain direction. These would be properties you have. And then they invented these extra properties that you could have, like your polarization or some other spin. Some other property or a magnetic moment is where that came from, frankly. So they knew that there was some property that accounted for the creation of magnetism connected with electricity, and so it was another one of these quantum style properties, like your momentum and your other things you have this property. And the argument is that because of Heisenberg, we're going to have this argument that you can't know these properties. So they're unknowable properties. The more you try to know how fast something's going, the less you can know about how, whatever, where its position is. So it's this argument that you can never know one thing without knowing less about something else, and like it's some sort of rule or law that somehow this is the truth. And Einstein's point was to try to point out how it can't be a law. It can't be some rule, okay, because I can create a circumstance where I can break the rule. So he's basically showing how you actually can know more about something's velocity, okay, and also know more about its position. That there's no rule that says you can't do that.
Up, and if they're spinning clockwise, we say they're spinning down. So they can be spinning up or they can be spinning down. Einstein and his colleagues found that you could have two particles.
They didn't find any of this stuff. It's a thought experiment. Yeah. There was no findings.
Set them up in such a way that each of them is in this funny mixture of both spinning up and spinning down.
All right, so that's nonsense. That's not what Einstein proposed. Einstein proposed the simple right-hand, left-hand glove rule. So you could have a system that produces two things at the same time. One of them's polarized this way, the other one's polarized this way, for example. They could have a property that's inverted, and they're created at the same time. And then, in space, right, they would move around and do things, but they still have their polarization, right? One's this way and one's this way. That's how they were made. They weren't in any amorphous two things at the same time. Einstein wasn't arguing for that. And the simple truth was, they were saying, this is quantum property. But if I do detect this one, and I figure out he's polarized this way, I know this one's polarized this way. So I know something about its quantum blah, 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 and I didn't lose any other information. I didn't lose position information or any other quantum information. I just gained information about one of its quantum properties. This is what it is going to be. And so it can't be this rule that this is unknowable mush.
50% chance of each. That's the weirdness of quantum mechanics. 50% up, 50% down. And you can set them up so that they're both in this mixture.
Okay, so that's not, again, so he's just putting crap in Einstein's mouth. And Einstein never suggested that they're switching back and forth between these things or any of that crap.
Half up, half down. And you can take one of these particles, put it in a box, bring it way up.
What a retard.
Over here, say in New York. Take the other particle, put it in another box, bring it over to California. So here they are, each in this fuzzy mixture of both spinning up and spinning down.
Okay, so again, that's just bullshit. Okay, that's not what he proposed.
You go over to the box in New York and you open it up, and as we were discussing earlier, the particle snaps to attention. Say it snaps up. It knows it's being looked at, measured.
This is what they turned it into. So this is how they got out of Einstein's thought experiment, which is clearly, you're gaining free information.
What Einstein and his colleagues found from the math was, it
Bullshit.
said that at the very moment that you open the box in New York and find it spinning up, the one in California also snaps to attention, spinning down, even though it's 3,000 miles away, you didn't do anything to it. In the reverse experiment, go over to the one in California, open the box. And
So again, this has nothing to do with the real history. That much I think can be known. The real history might be a little different than I stated it, but the fact is that Einstein's thought experiment didn't have woo in it. Didn't start with the woo premise and then move, make an argument from the woo premise. Okay, so Einstein didn't propose that either they're superimposed or either that they are somehow not knowing what state they're in.
say it's spinning up. At that moment, the math says the one in New York should spin down, even though there's no connection between them. Einstein called it spooky.
Well, yeah, and that's not what Einstein suggested. So again, he said it would be. Okay, he didn't call it this spooky action. He called with the other story spooky action.
Spooky action at a distance. You do something over here and it somehow affects something over there. And his hope in some sense was that this was such a crazy implication of quantum theory that if the people who were in favor of it learned about this feature, they'd say, oh, there must be something wrong. Now when he showed this to people like Bohr, they did. run around a little bit at first, a little perplexed, and they basically...
All right, so this is, again, him paraphrasing the history. As I understand the history, Bohr wrote a response that nobody can understand. It's completely incomprehensible mush. They published it with the pages in the wrong order, and people didn't even notice. You know, so, I mean, Einstein got back crap. The same crap they got from the Schrodinger example. Just crap. You know, the cat is dead and alive. That's right. Yes, that's right. Except if we invent different universes, and then we can kill it any time we want to. You know.
said, maybe that's just how things actually do work. How could you tell? Well, you wanted to actually do the experiment. You know, this is just math at the moment. You couldn't do the experiment in the 30s when this was really put forward.
And they still can't do the experiment. The experiments they're doing now are based on so many assumptions against all this LIGO crap. 4 million, you know, different little mechanisms and procedures they go through, thinking they are doing a certain thing when they're not. They think they got apples in the machine. They really have oranges, and it's not going to be the right answer, but they have oranges in the machine. They think they're apples.
40s, 50s, 60s, 70s, you can do it. By the 80s, you could do it. And people did the experiment. And just as quantum theory predicted...
No, people didn't do it. Okay, so this is the Allen aspect bullshit. They're relying on their understanding of light polarization. They're using polarization, not spin, in the experiments. This is just all horseshit. shit.
This guy spins up, that guy spins down. This guy spins up, that guy spins down.
At a distance, at what distance? The experiments were done, what they over?
11 kilometers. They didn't. There's no reason why it couldn't be arbitrarily.
One could be.
Right. So the most modern experiments, and again, there were claims of, you know, all these different, you know, distances, and there's been experiments that have been debunked as crap. But again, these are really complex, impossible when you think about it. Actually, I mean, measuring photons that are supposed to be entangled at great distances, like I'm going to see the same photon. These are very unrealistic expectations. They're insanely unrealistic in the fact that we know that the photons that are going through the atmosphere right now are interacting with atoms. They don't have a free ride. There's no, you know, the speed of light in atmosphere is different than the speed of light in free space. I mean, it's a small difference, but it exists. And there'd be no expectation that you could see two entangled photons, that you could actually select them out of all the photons in the universe and say which state they're in. It's just bullshit.
Here on the stage, and another could be on Mars.
It could be on the other end of the universe, and it's as if these two particles have a quantum entanglement. That's where they're.
Now here's the amazing thing to me about that. Not just that it exists, but that you can take it.
Not just that it exists, because you proved it with obtuse and bizarre experimentation.
And do something with it. What can you do with that?
What can we do with it?
So, I mean, it's this whole smoke and mirrors argument, right? I mean, they're not showing you Jesus walking on water. They're showing you a bunch of smoke and mirrors that have Jesus walking on the water, right? They obviously need a huge ton of this bizarre technology to make this claim that they have produced the image of Jesus walking on the water. So it's no big surprise they can find whatever the hell they want in that machine.
One of the things we can do with that idea of entanglement is make money. Well, maybe somebody.
Yeah, it won't make anything productive. So this quantum computing thing is just so funny, because, you know, I'll draw something in this video anyway. Because it just there's nothing really to draw. I mean, you know, computer information is now stored in what are called bits, right? And the bit is either an on or an off, an on or an off. You know, circles and O's is what they draw it as. And they're claiming, because, well, we'll give it a third property, Y. Okay. So now it can be on, off, or it can be Y. But that's not what they're really saying. Okay, they're saying they're all Y's, and Y equals both on and off. You know, so Y equals both of these states. And so, you know, this means that you can essentially, you know, you can find anything you want to in the order of the bits. So whatever you want to see in the image, you can see, because now I basically said every pixel can be either pixel. So, you know, if I was to make an on, you know, you can make an image with X's and O's. So they're basically saying, well, now I can make any image because they're all Y's. And the Y's can be converted to an X or an O to my suiting. So I can make a Richard Nixon, or I can make a, Holy Mary, or I can draw anybody here. So I can get any answer. And one of those answers is going to be the right answer. Okay, so say to a mathematical problem. So what they're basically saying is they can they can go from the question, okay, the process, the equation, and they can just jump over the whole process of doing the equation and just get to the answer. They'll just jump to the answer. And they won't have to go through any mathematics. They won't have to do any problems because the answer is already in there, in the sense that it's there as a possibility. Right? So because it's possible, they can say, I can jump to it. Because if it's one of the answers, I can claim it's all of the answers. Or something. Whatever. It's just such mush.
There may be a time when somebody does make money. What we can do is we can make a new kind of computer, a kind of computer that nobody ever even thought about, or could have even thought about before there was quantum mechanics. But this computer can solve problems that are essentially impossible for even the fastest imaginable, ordinary Bill Gates type computer.
It really can't do any of this because, again, it's still just pretending like you can jump to an answer, that you don't have to actually add 2 plus 2 plus 7 plus 16 and get an answer. You can just jump to the 16. Jump to the answer, which would have been some other number.
To do. So there are problems that are so hard that not just the fastest computers of today, but the fastest computers we could even imagine building cannot solve within our lifetime.
Now, briefly, how would you take the spooky action at a distance and turn it into a computer? Just roughly, how would you do it?
So the idea is that, as we know, as many of us know at least, information stored in our computers is what we call bits. A bit is either 0 or 1, and we represent that by, say, a spot on our CD-ROM that's either burned or not burned. Now, in the quantum world, the bit is called a qubit for a quantum bit, and the 0 and 1 is up or down, the spin being up or down. Now, the cool thing is that...
So they don't even, the whole spin thing, right? It's not even spin. They concede. They don't know what this property is. And they really don't have any way of detecting. It's just bullshit.
If I have one bit, it can either be up or down. And that's all, either up or down. Quantum mechanically, it can be
It's plus
both.
or minus, it's binary. Yeah.
Right, but quantum mechanically, it can be both up and down at the same time. Okay, so you've got both possibilities. Well, that's great. Now let's say I've got two of them. Now, if I've got two ordinary bits, they could be either both up or both down, or one up and one down, or the other way around. One of 4 different possibilities. Well, with quantum mechanics, it could be all 4 possibilities at the same time. Now, with 3 bits, there's 8 different possibilities, and in quantum mechanics, you can have all 8 at the same time. Now, let's say I had 100 bits, which is nothing strange. You've got billions of bits in all of your computers. Let's say I just had 100 bits, okay? Then the number of different possibilities that I could have all at one time with quantum mechanics, if I allow them to be entangled, is more than the number of particles in the entire universe.
So you're...
Says him. I don't think you can make the arrangement of the universe out of that number at any one time. So you can just say, oh yeah, well, I can do a part of the universe at any one time. But because they're entangled somehow, I don't have to spend any time doing it. They all already did it, okay, because they're all entangled. They don't take up any time to be a certain way. They're every way at once. So you're basically saying I did the whole equation in no time. I didn't spend any time actually doing 2 plus something, 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 because it all happened in quantum space, and therefore it took no time.
saying with only 100 bits, you would have...
Actually, it's 300, but never mind.
Okay.
I made a little error in my
Yeah. That's minuscule.
That's minuscule, that's right.
And that gives you, in a way, a computer equivalent to the brain power you'd find if every bit and every particle in the universe
Yes.
was a bit in your computer.
It means that you can do more calculations at one time. In other words, all those possibilities are stored in the quantum computer.
Well, I guess you could do an infinite number of calculations. Well, an infinite number of this huge number in per second that would be the consequence of 300 bits. So you're multiplying, 4, 8, 16, 32,
One time. So you can do in parallel more calculations than there are things in the entire universe. That's a power that we can never realize with ordinary Bill Gates type computers. So that's where entanglement can really produce real results. So this thing that was so
I imagine in building this computer you have a problem because every time you try to access it, you're looking at it and kind of messing it up.
Yeah, so you got to be careful.
So again, this looking at it thing, There's no looking at it. There's only interactions in the universe, and yes, our lookers are dependent on an interaction. Everything we do is an interaction, and all the stuff happening that we're not paying any attention to are interactions. Everything's getting looked at, interacting all the time, and we don't have to be, we're not essential to this looking at bullshit.
Never to look at it. No, I'm sorry.
This follows my theory of current computers, that you can do anything with a computer and it'll never break down as long as you don't use it.
Well,
Yeah, well, great joke.
yeah, well, it's an analogous idea. So we should never look at the computer.
It seems like there's a spectrum, to me it does anyway, of interpretations, ranging, say, from Niels Bohr on
Yeah, wacky to wackier to wackier to wackier.
one end of the spectrum, who felt that the getting from the quantum world to the classical world, that there was a discontinuity, that you reached a barrier, everything, you can measure things in the quantum world, but then when you want to measure baseballs and us, you had to jump over that barrier, now you're in a new world, new rules.
Like I said, this is just the argument about should we let the Pope do science?
New game, and don't ask why, just calculate, do it, Then on the other end of the spectrum, you have things like an agent that takes care of everything and decides what's going to, or you have Max, who says, it all happens, everything happens, it's not a probability, right? It's not like this could happen. Everything does happen, and only it happens in worlds that we're not, right? These worlds are not out there necessarily, right? They're like all mixed together. Right? So I'm really interested to hear where you think we are in this spectrum. Is it
Yeah, it should be back. A little pause there. All right, so we're talking about a spectrum or something. You can be on some spectrum of woe.
or can you be open to all these possibilities at the same time, or all these realities?
Right, can we just sit there and say, well, who cares about this fact thing? We'll just fudge it, yellow's green and, same difference.
Which end do you want to start? Closest to Denmark, or do you want to go?
Well, I don't even know where you guys are on this.
I mean, maybe I can start. There's, I think the right thing to do, of course, is to be open-minded about this. We have several ways of trying to make sense. That is, we have several ways.
No, you have several laws about how you do physics, and you have these sort of rules about how you're supposed to do science. And you're supposed to do this repeat thing. You're supposed to, make sure you've covered all the bases before you draw conclusions. Like, there's no way it's possible. There's this. You don't do this Feynman lazy bullshit where you say, well, I can't figure it out. I'm really smart, so you'll never figure it out. So just give up.
Of trying to get beyond the shut up and calculate attitude. And as a matter of fact, some of these ways make different empirical predictions than one another. And these are being developed. These are new scientific theories. There are a bunch of, I think, very promising ones on the table. And people are studying these.
Yeah, which ones are those? String theory? I mean, well, what? Very promising. How?
And people are trying to parlay them into concrete predictions that we can then come and do experiments about. And it's being turned back into an ordinary scientific problem, which I think is the right thing to do with it. It is...
Yeah, but none of the solutions have anything to do with finding the real causes and doing this whole unification thing and figuring out that this is a simpler process, not a more complex one. All the answers seem to require the universe to be infinitely more complex than what the facts really do indicate. Most of the facts, 99% of the facts indicate the universe gets simpler, not more complicated.
There is a... Let me say a little about what Brian said about entanglement before Brian was expecting me to disagree with him, and I will a little bit.
Well, I had a part two that I never got to. But
Okay, good. So maybe this is part two.
Yeah.
Look, what Einstein pointed out this non-locality, this phenomenon of entanglement. It's not exactly true that his attitude was, as soon as people hear about this, they're going to say, oh, it's crazy, and they're going to abandon quantum mechanics. He thought he had a strict logical argument, okay, that if you made certain assumptions that sounded plausible, he had a proof from this phenomenon of entanglement that quantum mechanics must be incomplete as a description of what's really going on. And Bohr's reaction to it was an interesting, curiously philosophical reaction to a very concrete...
So he's going to paraphrase the Bohr reaction, which nobody else can understand, but fine.
Scientific argument. Bohr didn't say, well, if that's what the equations say, that's what's going on. Bohr, if you read his response to the Einstein-Podolsky-Rosen argument, essentially says something like, this word really, what's really going on? I don't like that word so much. That's kind of old-fashioned.
So that's very scientific, right? The idea of there being real causes and to the effects. And so again, this is just a huge assault on the whole concept of cause and effect, and a mechanical universe. It's just really opening the door to some sort of universe being run by, whatever, green chalk, some sort of foreign entity, gods. So really, this is just, Bohr was, just dragged physics back into religion. That's all he was good for.
It's a little bit nerdy to be all in a fuss about knowing what's really going on. It's time to get beyond that. It's time to learn that there are certain kinds of questions about what's
right. You don't ask because God is going to tell you shut up. Whatever. You don't ask. You don't ask questions. Just pray and bow. Ugh.
really going on. That it's naive or old-fashioned or archaic or somehow.
So, but where are you along the spectrum?
So it's just such a huge irony that there's so many of these modern physics devotees who are passionate atheists, and it's like, what the hell? How does it make any sense? You're using your physics to basically say that somehow it's reasonable to believe in demons.
I'm with Einstein on this spectrum. Those are the only questions at the end of the day worth asking. And I'm not in the mood to learn that, this notion of reality, who really cares about that, and so on and so forth. I think, once again, something that Max and I are completely in agreement on here is those are the questions to ask. Bohr made...
Yeah, there's nobody asking them. So again, there's no point in this conversation. You're given these silly choices. Copenhagen woo, or many worlds woo, or random bullshit woo. They're all just woo choices.
I guess the best word...
Nobody's saying, well, why don't we look at the slits and see if they're doing something to fuck up the photons. Maybe the surfaces have something to do with the experiment. Maybe. It's a slight chance. They're not even doing that. They're not even giving it a slight chance that the surfaces actually have something to do with the experiment.
Made very oracular sorts of pronouncements.
It seems that the further along we get in thinking and experimenting, am I right about this? I get the impression that the quantum world keeps creeping more and more into the big world that we're comfortable with. You seem to be able to determine things about bigger...
No, that's just ludicrous, right? There's just absolutely no evidence that this thing is relevant to anything in the real world. The real evidence is it hasn't done anything. Again, quantum mechanics didn't invent the blue laser, or the blue LED, right? It took 27 years of doping and changing and manipulating and fiddling with cause and effect experiments. No theory got them there.
Things through understanding these small things.
That's absolutely right.
Yeah. So that seems like that spectrum is spreading out, mushing out. It's kind of joining.
Yeah, I think it is. I think as to your question as the spectrum and whether one should even take positions in them, first of all, I think
So again, there's not even like a gravitational wave of quantum, right? Quantum hasn't done a damn thing except promise you, it's going to give you perfect encryption. It's going to give you a quantum computer. It's going to do, but none of this shit is anywhere close to being real. So where exactly is this quantum doing anything real? It's nothing. There's no example of the quantum miracle anywhere in our lives.
we should clearly keep an open mind. Second, I think the fact that different physicists have slightly different viewpoints about this is not a weakness of us as a community, but a strength. Because we will...
So again, more bullshit, right? It's not. It's a strength that we all have different religions. I believe in Mohammed, and he believes in Jesus, and this is so silly. But there's not an evolutionist anywhere around. So yeah, this is a bunch of it's a real strength we have, that we have completely different understandings of reality. No, that's not a strength. That's showing that you don't know what the fuck you're talking about.
We'll all work harder on the things we're excited about, and it's much better that we bark up many trees than that we all bark up the same tree, right? And I think you'll agree with me. But
the truth is one tree. You want to find it, and that's when you want to start barking. You don't want to start barking until you actually found the right tree to bark at.
it's just that many extremely practical discoveries that were made, which were useful and even made money, like...
Okay, so this will be a lie, a huge fucking lie. Something that made money, that was a real quantum invention.
computers were made because someone was really passionate about some philosophical question. Einstein was trying to understand the nature of time. I mean, how much more philosophical can you get? Discovered this formula.
Right, and he discovered nothing. I mean, just this silly idea that there's some sort of frames of time, and so it's this idiotic notion that perception has something to do with what actually happened. So if I move between two explosions that happen simultaneously, and I move somewhere different positions, that somehow I've changed whether the things were actually simultaneous. What? No, I didn't change anything. I got information at a different rate. That's all that happened. There's no time change. Nothing changed in the universe at all. I moved my position. Yeah, so my perspective changes. Nothing else changed.
E equals mc squared. It gives us the nuclear power, which might be keeping these lights on tonight. Very down-to-earth practical discoveries come
Right, it has nothing to do with quantum crap again, so that's all bullshit.
from just curiosity-driven desire for understanding. So I think it's great that there's a spectrum, and I never try to persuade colleagues who are psyched about a different part of it to do other things, because I think we don't want some kind of ontological monoculture. We don't want everybody running.
Again, yeah. Why don't we want that? Why don't we want the truth to be respected by everybody? Oh, that would be really great, frankly. So this silly notion that chaos and slop and mess makes for a great living. No, it doesn't. It's just a pile of shit. People speaking different languages, not a great idea. People speaking having different religions, not a great idea. No, bad idea. Doesn't do a damn good thing ever.
Windows.
Diversity really does suck.
You want to approach it?
Well, as a Mac user, I'll certainly agree with that. But no, I absolutely agree. Let me distinguish between two different...
That's another good example, right? I mean, the two, Microsoft and Apple, two shit companies, right? Just gouge the fuck out of us for 30 years. That should be what we have as an example of our choices.
different kinds of open-mindedness with respect to just the question we're asking. And it goes back to some of the things that David has said. It seems to me there's two ways of categorizing the different views that we have about quantum mechanics. One is different interpretations of quantum mechanics that give the same result. Your many worlds interpretation is going to give the same result as my shut up and calculate interpretation.
Well, yeah, duh. We all have to argue the evidence. Duh. Anybody who's coming up with a theory that's not consistent with the evidence would be pretty stupid. So yes, they have to come up with an explanation. So yes, you're saying, well, yes, that gun did shoot him, and that gun does have my client's fingerprints on it. But I'm going to tell you a story about how the fingerprints got there. See, the Invisible Man stole his fingerprints from his house. He took a little piece of plastic tape and stole his fingerprint. And then he stuck it on another thing to make a mold of it. So he reversed it again, because you need to reverse it again. And then he stuck it onto the gun. And see, that's how the crime was. Yes, the Invisible Man setting my client up. Clearly, that's the explanation. That's the only way it could happen. We've proven all the other theories can't work. Like my client did it. Yeah.
But it may be that one or the other, or any number of other ones that give the same results, will yield different insights and allow us to make progress that wouldn't have been possible had we stuck with one particular interpretation. And that's very important to have different ways.
Yes, it's very important. Sometimes mistakes are happy accidents. Yes, la 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 la. But you really don't want to depend on happy accidents to do all of your progress, do you? No, you really don't. Ugh. This is a pitiful bit of rationalization, right? That somehow not knowing what we're doing is really good for knowing what we're doing. No, knowing what you're doing to have a good outcome, it really helps if you really do know what you're doing. That's even better.
Of looking at things, and as you say, have different people working up different treaties. But to me, even more exciting, and that's already really exciting, but even more exciting is different interpretations of quantum mechanics that predict different things. Because then I come into play. You see, I'm the odd man out here. I'm the only experimentalist. I'm the guy who works in the lab and tests these things. I'm the real...
Yeah, I'm sure you do. Right. With your little magical I found it machine.
Quantum mechanic. The guy who's got the wrenches and the...
I thought a quantum mechanic was a little thing, the guy with a little wrench fixing the nano machine. You need a quantum mechanic.
So if somebody predicts something that is different from what quantum mechanics predicts, then I'm really happy because I can go in the lab and I can find out whether that's right or not. And you know what gives an experimentalist the great...
Oh, jeez. They shouldn't even, they call these experimentalists. I mean, that's just amazing. Sorry. they're so distant from because there's just so many assumptions. You can't call it an experiment anymore.
It's pleasure to prove that the theorists are wrong. So it doesn't matter. Someone's going to end up being wrong. So that means no matter what, it's going to work out well for me. Because if there's two theories and they're different, then one of them's wrong.
Yeah, and what if it's the experimentalist who fucked us with his silly story he was telling about all these things he did that he didn't actually do, like in the case of LIGO. The experiment is a big convoluted pile of shit. Okay, so and someday it'll be proven it's a pile of shit. So you are on the hook.
And I'm going to find out if I'm clever enough, or at least if my graduate students are clever enough.
But you know, I'm Swedish.
Now, it's all depending on what newspaper's paying attention and decides to publish the story that you did it. When, maybe you didn't.
And we love to say bad things about Danish people. And the reason that many physicists referred to the Copenhagen fog when they described Niels Bohr was because he was deliberately vague on some things, and it's not even clear whether what he predicted was always right, because he said this applies to atoms. And if you really pushed him and said, is it going to apply to something with 10 to the 15 atoms, there are some things he published which suggest that he thought it didn't even apply, and that's something you can now start to test. You can start to, there are these beautiful experiments trying to put little mechanical cantilevers in superpositions in quantum computers, and Hugh Everett, right, who's published this idea 50 years ago about many worlds, he made a very firm prediction saying that quantum mechanics is going to apply to your experiment no matter how big it is, and therefore quantum computers are ultimately doable. He laid down his prediction, whereas maybe the Copenhagen fog said, just don't answer that question. And I prefer people who at least will have the guts to just make a firm prediction that you can falsify.
Yeah, and there are people who are predicting that I can't make a quantum computer with more than about 400 bits. And you're probably aware of these ideas that say there just isn't enough information in the universe to be contained in a fully entangled 400-bit object. Well, 400 bits. I mean, so far we've done maybe 2. Okay, this is what's known as a 2-bit quantum computer.
Thank you very much. Thank you. You'll be back, ladies and gentlemen.
You're taking orders afterwards.
But but 400 isn't that much different from 2. And so
it's about 398.
Yeah, okay. But, I mean, I'm optimistic that maybe within my lifetime I'll be able to make something with 400 entangled bits.
I bet a lot of us are wondering the same
Yeah.
thing. How do you go about entangling a couple of particles? Just like you have about 5 seconds.
Okay, so the particles I work with are atoms, okay? And the way I'm going to entangle them is I'm going to put this one into a superposition being up and down. This is this ordinary quantum uncertainty that we've been talking about. And then I'm going to bring it in contact with another atom where the force between the atoms depends on whether this thing is up or down. And then something's going to happen to this other atom because the force is different. Then I'm going to pull them apart. And now, what the state of this atom is going to depend on what the state of this atom is.
This is really getting silly, right? Entangled atoms. Too silly.
In this funny, spooky action at a distance way. So the way I do it in practice is I've got a little container for atoms.
So they're basically saying the atom has some sort of property, okay, that's vague. It's in both states at once. What property would that be? Where the electrons are and where the protons are? And the neutrons? What property could there possibly be that you could entangle? Oh, that's right. There isn't any. It's like all these magical antiparticles. Well, where are they all? Where is all this anti-universe? Where is it? Is it inside the atoms? All of these anti-things? Where the hell are they? It just doesn't make any sense.
And I got one atom here and one atom here. And I know exactly how to put this one into the superposition state. It sounds weird, but I do it every day. Huh. Okay, so I've got it now in the superposition state, this thing that I don't know which way it is.
When you say it's in superposition.
All right, so says him, right? So he just says him.
It's in a lot of states at once, or it's in these two states.
It's in those 2 states at the same time.
At the same time.
And
It's already a little
I'm going to get one of the answers, but I have no idea which it's going to be. Then I've got this other atom over here, and I've got a container for it. And then I bring the 2 containers together, and I do this all with...
You mean all you have to do is bring them into physical proximity? But these are any 2 atoms?
No, I have to choose the right atom that has the right properties, that the force depends on what the state is, and so I can't just use any...
In other words, you have to read the manual.
Yeah, that's right. And so that's what we've done. We've figured it out, and we figured out, well, we can do this with rubidium atoms.
Oh,
And we use some tricks that I don't want to talk about.
No, of course not. No, there are children.
That's right. But we use exchange for the people who are the cognoscenti, and we bring them together, and they come apart, and they're entangled. And it's not very hard.
Oh, you got that?
Well, it's not very hard to do. The key thing with entanglement is the state of this thing depends upon what the state of this one is going to be, even though I have no idea what the state of either one is.
But when you open one box up,
then I know what the other one's
going to
be. Now, here's the thing that really I think weirded Einstein out. Was that he says, look, here's something, okay? And here's a particle. It's sitting over here. It's in the box. When I open up the thing, I'm going to find that it's either up or down. Now, if I have any kind of a notion that that the world works in the way I think it does, then what it means is before I open the box, then it must be that that thing was in the state up or down that I'm going to see when I open it up. And if that's true, then this business about entanglement has to be crap. And it turns out, I mean, so what Einstein was hoping was that the business about entanglement was going to be crap, but what it turned out was, and there's experiments that show this, and that's the amazing thing. Let's come back to the experiments. That if you say, I've got a thing here, and this thing here has a property, and that property exists before I look at it.
So again, we just have this promise that the experiments confirm this. So again, it's just, do you really? Wasn't somebody just said, we did it? Isn't that what isn't that the extent of the proof that your experiment actually says that, or proves that, or indicates that, is that you say so?
If you insist that that's true, you're wrong. Now that sounds like the most reasonable thing you could imagine, that a thing sitting here has a property that exists before I measure it. But we now know that at least is wrong. You'd agree with that, right? Mm-hmm. That part is wrong. Mm-hmm. Now, whether some grander idea of reality is right or not, that remains to be seen. But at least that...
Well, I mean, the idea that something isn't a thing in a state is already such a leap. Then why not? Where else are you going to go? You've already created a magical universe because the chalk isn't really chalk. It's only chalk because I'm looking at it when I stop looking. But over here somewhere it can do anything it wants. You know, hobgoblin.
Idea of reality. The thing sitting here has a property before I measure it. We know that's wrong.
Can I just amplify that point, because it's a really important one. So just to put it in more familiar terms, what some people suggested was, well, when you measure and you find this one's up and that's down, or this is up and that's down, what's really going on is much like a pair of gloves, okay? You have a right glove and a left glove, and let's say you put them down, you pick one up, you don't know which one you picked up, you put one in one box, you take the other, you put in another box, you bring the boxes to the other sides of the country. When you open this one up and you see right, you immediately know that one's left. Is that mysterious? Not really. Not at all. So people thought maybe that's what's really going on with these particles.
But it sounds like, I mean, I'm sorry, I thought you were done. Sorry.
So what we learned is that that's not right. So the gloves...
So we learned that it's not right, but we didn't learn it like in some obvious way, like in some simple way, in some way that's like gloves. The way they learned it is in the big smoke and mirror machine. Okay, that's the machine that's telling them that it's not gloves.
Themselves are somehow always in this mixture. Even before you look, they are in that mixture. They're not in right-handed or left-handed before you look. So if you open up, you find right. It wasn't right before you looked. More or less we learned, although there are ways of interpreting this which are more subtle than that. You actually still have to accept that things were in this mixture before you looked. And that is a very strange reality to buy into,
well,
but that's what we're forced into.
That's what I was going to ask you. I mean, it sounds like...
We're forced. We have no choice but to create these wooey properties that we don't understand, like spin, and then tell you that the spin is... not that it's spinning up and down at the same time. So the property that we can't even identify as a real thing because it's not really spinning is doing this two ways of doing it at the same time. And we proved it with these volumes of easy to illustrate experiments now.
You're describing something truly spooky in that it's not just a question of having packed and forgetting where you put the right glove or the left glove.
Right. Yeah.
Somehow we're suggesting, you're suggesting, that until you open one of those suitcases up, it could be either the right or the left.
It's not that it's neither. That it's the standard view of this is that it's in a situation for which asking whether it's the right glove or the left glove just somehow doesn't make sense. It's like asking...
Right, so it has a property that allows it to interact with the universe without interacting with the universe. But this is only because it's not interacting somehow. Somehow it's magically escaped the real universe where we know everything is interacting all the time. So, I mean, if you really think about it, gravity's on all the time. It doesn't just go away. You don't go into some space where there's no gravity affecting you. There's no such space anywhere. But they're sort of saying that they're saying you can somehow avoid the fact that you're going to be constantly interacting with the real universe because the universe is densely packed full of this force stuff that's bouncing around in your room right now. How do you not interact with it as either a glove, right-hand glove, or a left-hand glove? You can't interact with anything that ever you encounter, any piece of gravity or piece of magnetism or piece of electricity or piece of light or piece of anything. So how could you ever be in a not I don't know who I am state? Because there's no place you can go in this whole fucking universe where you can evade this force of this bent space thing or whatever. And the bent space has to know whether you're this way or you're that way. It's going to know.
It's like asking. It's like asking whether a tuna sandwich is a Democrat or a Republican. Okay. It just doesn't make sense on the standard view. Now that doesn't rule out at all that there's some story about what's really going on there. If I have something in a box and I ask, is the thing in this box a Democrat or a Republican, and the thing in the box turns out to be a tuna sandwich, you find out that the question was inappropriate, okay?
Well, that's just a silly example because they're saying it's a real property, this spin. So you don't say, they're not going to allow you to say spin never existed.
It doesn't mean that there's no reality about what's going on there. It means that the reality was very different from the one you were assuming when you raised the question in the way you did. It's one thing to say, it looks like we've got a big challenge here. It looks like we're going to have to radically reconceive our picture of the world in order to...
So instead of just saying, we don't know what the fuck we're talking about, that's what they should just say. We don't know. We don't have any good answers. No, all we have is silly ones. So I guess we got to try harder until there's enough information to have a rational answer, because we can't come up with any. Instead of just saying that simple thing, this isn't about asking the wrong question. I mean, it's not about figuring out whether tuna sandwich is, has a philosophical perspective. We already know that's not possible.
Tell a coherent story about what's going on here. It's quite another thing to say, as Bohr did, the thing to learn from this is that reality is a bad and dangerous word to be using altogether.
You know, when those of us in the lay world hear these amazing descriptions of reality, it's very easy for us to say, and I know people who say this, well, you seem to indicate that anything...
You could have said silly, right? Instead of amazing, you could have said silly, right? That may have been a more appropriate word, right? I mean, my reaction is silly. It's not like, oh, it's an amazing... No, it's amazingly silly.
...is possible. And quantum physics is weird. So...
It's silly.
Someone finds it easy to say, I just thought of something weird, so that's probably reality too. Now I know it's an illogicality. However, when you hear so many weird things, and we don't have the tools.
Yes, they keep defending very, very bad science, and so they open the door to a bunch of really bad scientists, right? They're given license to making anything up because they seem to cling and jump to made-up stories, just stories.
With which to test these statements ourselves, because we either don't have the math or we don't have the machines and the experimental equipment. It's very hard for us to not start drifting in our thinking into anything goes kind of thought. What can save us from that?
Well, I think one thing that you always have to keep in mind, which we have discussed before, is that however weird quantum mechanics is, and however strange a reality it might be revealing to us, it makes these very specific, definite predictions of fantastic accuracy when compared to experiments.
Okay, that's just such a pile of shit. It doesn't predict anything that you didn't already know. Oh. I mean, again, he's saying there's something about this special math, right? And all it is statistics. They observe a system like a roulette wheel, and they determine, they chart the outputs, and then they say, okay, well, if I put these outputs in this formula, it'll convert the outputs into probabilities. It'll just tell me based on, how many, I did 1,000 observations and 20 of the observations were this, 20, 20, 20, 20, whatever the number would be. And I found very perfectly that it matches this probability of equal probability. And with huge precision over more permutations. The more permutations I do, the better it gets. The more decimal places I can narrow it down to. There's nothing magic in that. There's no formula that did anything great. It's just statistics. And processing statistics.
And most things that you dream up in your head, don't do that. And that's the critical distinction. But can I just ask Bill one question? Because
what a pile of BS.
I'm really curious about this. When you say that you like the shut up and calculate approach, I'm wondering the following. If I came upon a box, and I gave you this box, and it had this miraculous property that any question you asked it, it could give you the answer to anything. What will happen when I throw this particle against this? What will happen had the universe begin? All the answers pop out.
All right, so none of this happens, right? This is not what quantum mechanics does. The box is transparent. You have to see what the thing is doing. I mean, this is just such a lie that they have any theory or any equation or anything that ever predicted anything that you didn't already know when you placed it in the variables. Connecting variables to outcomes is not miraculous. Adding 2 plus 2 and getting 4 is not miraculous. I see 2 trees over there, 2 trees over there, and I figure out there's 4 trees, and I predict there's 4 trees. That is not predicting.
Would you feel that it was time to retire? Because all the answers would be there, or would you feel the need to, I want to open the box and figure out how it's doing that. I want to know the reality that this box is using to yield these answers. Would you feel that?
Well, absolutely. In fact, if you had a box like that, then one thing it could tell me is where the electron ends up when I put it through the double slit.
So it's just about variables. That's all this is. And they're saying they have some magical formula that's identified the cause for the effect, and that's the very thing under dispute. Nobody's disputing the effect. And again, Newton will figure out the effect pretty accurately also. So I mean, this is just sort of a lie that somehow there's some new thing that's changed, and we need quantum mechanics for me to calculate how much heat this will generate when I throw it when it hits something. No, I don't need quantum mechanics to do that.
And if it could do that, then it means quantum mechanics is wrong, which is fantastic.
But let's say it didn't do that. Wouldn't you still feel the need to probe the inner workings? So when you say shut up and calculate, I give the sense of, it's giving me the answers, and that's good enough.
So you're absolutely right. So when
So again, it doesn't give you the answers. It's just silly. Answers in, answers out. I mean, really, it's that silly. Observation gave you the answer. You just put the answer in a form that's prettier.
I take the shut up and calculate view. One of the reasons why I was presenting it was because I wanted to make sure that the orthodox view was presented among all of these heretics that are here on the stage. But one of the things that I think is true, both of my view, the shut up and calculate view, and of all of these other views, except for ones that aren't quantum mechanics, is that they're unsatisfying. They're fundamentally unsatisfying. And the genius of...
Well, I thought you said it was all great fun to not have the right answers and all have diverse answers and...
Einstein was, he realized in a deeper way, I believe, than most of his contemporaries, how unsatisfying quantum mechanics was. And the reason we're having these kinds of discussions is that each one of us feels unsatisfied by quantum mechanics as it stands now, and each one...
All right, so they're having a bunch of unsatisfying, enthusiastic fun. So it's unsatisfying, enthusiastic fun. See, they don't know what the fuck they're talking about. They don't even know whether they're happy or sad. Ugh.
One of us has our own reaction to that dissatisfaction, and I'm not satisfied with any of those reactions.
Well, so many of us have different thresholds of satisfaction. Some people can be satisfied believing that the world sits on the back of a turtle, and they're perfectly happy with that. And other people need to go much deeper, and other people need, as Einstein did, to go way beyond what anybody told them was the actual fact. And and yet, as we search out for these different reasons, the different solutions to our curiosity, it's amazing
how long this goes on.
Answers, and we are barking up different trees, and that is very satisfying to us as a group, as a community, as a species. It's really delicious. We're going to have to wrap up now, and I want to thank Brian Greene and Dave Albert and Bill Phillips and Max Tegmark. And I want to thank the sponsor of tonight's program, which is supporting the Big Ideas series at the festival, the John Templeton Foundation. But I want to ask one last question as we...
Yeah, I wonder if John Templeton, if he could have chose better. I wonder if he's still alive, right? He's probably a dead guy.
As we wrap up, a quick one that you probably can answer this in one or two sentences. The question is, do you think that there's something fundamental missing in the notion of quantum physics? Are we going to 100 or 200 years from now look back on this time and say, gee, how naive they were then?
No, I say it's not even naive. Well, I guess in a way it is, because it's all this gullibility, but they're the ones duping. They're the ones way overstating. I mean, these overstatements are so obvious, that quantum mechanics has predicted everything, and with a certainty that's incredible and all this crap. It didn't predict a goddamn thing. It never predicts anything. So I don't even know what to say, yeah. I mean, obviously it's not a prediction when you already know what the fact that there's variables that will change the result. So when I already know it can go left, it can go right, it can go center, then obviously I'm not predicting anything when I say it'll go right in a certain percentage, it'll go center a certain percentage, it'll go left a certain percentage. It's not a miraculous prediction.
They really didn't get it. They were missing this fundamental thing. Or does it really capture it in a satisfying way that will continue to be satisfying? What do you think? Let's go down.
Well, clearly you're making a living talking about it, doing this crap. You get foundation money to keep on talking this horse shit.
I mean, I feel very strongly that a few hundred years from now, we'll look back at this time and recognize there were things that we were missing. And moreover, I think there's a possibility that when some of those missing pieces are filled in, quantum mechanics may not seem quite as strange as it does now. I mean, when we talk about, in
Yeah. It's not you'll be yes. The whole idea is that yes, there's real quantums. There's no wooey action. There's no spooky action. There's no ESP on the elemental universe. It's not doing any of this wooey bullshit. Yes, there was a mechanical cause to all the effects. That's what's going to be found out.
the old days, people thought that the sun went around the Earth, and then we got really clever and realized that the Earth goes around the sun. No, no, no. There's a sense in which the sun goes around the Earth. We see it happening. It's a perspective. It's an
All right, so no point. There's a sense that it's happening that way because of how we see it again. So we're going back to how we're seeing it rather than trying to describe what it's actually doing. So we already know our perspective can be dependent on how far we are from something, how close we are to something else, and we can get a distorted perspective. And the whole point of science is to understand the distortion and to compensate for it. And he's, doing the opposite, saying there's some good reason not to be careful and scientific in our observation, but no, go ahead and go with what it feels like.
awkward
Seems like is like.
one. It's an ineffective one. It's an inefficient one. But by God, it's one that's defensible. But it's much more transparent description of the world to put the sun at the center and take the sun's perspective.
Yeah, whatever. What you're going to be ridiculed for in the future is the fact that you pretended that you proved something else impossible. That you somehow demonstrated that you made enough effort to see reality as real, as cause and effect. That you did anything to defend cause and effect, and you did everything you could to avoid cause and effect. And that's the real truth here. You did everything you could to leap to the extraordinary answer and everything you could to somehow make the ordinary answer impossible. It's dismissible. There's no possibility of an ordinary answer. And you didn't do any science in that investigation. And that's proven by the fact that they haven't even analyzed the double slit experiment. It's proven by the fact they've never repeated the Eddington experiment from space. It's proven by all of this stuff where the elemental, the experiments that got them on the wacky road, they've never dissected. It's the sacred oracle of truth, their Bible, and they've basically said don't open it because it says silly things. Okay, so we'll just read the cover, leave it the way it is, and let's not see what it's really made out of. So the original mistake, the picture of Jesus walking on water, the Shroud of Turin, whatever, they won't analyze it because if they analyze it, they'll find out it's not what they thought it was. And they'll find out their whole reason for believing in this woo was wrong from the beginning. Alright, so enough of this crap. Sorry, long video. Not much to it, actually. So, I didn't know they were going to get quite that boring. But it's all free, and you really don't have to listen to every video. And, blah, 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 blah. I would go to the playlist if you really want the videos that matter and the subject videos. And, pay attention to the 4 major subjects, the most recent videos on those subjects: magnetism, gravity, charge, and light. And that would be all for now. Yeah.